Okay, in this problem, I've got a power cycle shown here. It's a PV diagram, 1 to 2, 2 to 3, and then 3 back to 1. And it gives me a couple of things. First, I know the change in energy from 1 to 2 is 15 kilojoules, and the heat transfer process 3 to 1 is 10 kilojoules. So I want to find the work and heat for each process. And I want to find the thermal efficiency. Okay, so let's start, since I got PV data, okay, let's start by calculating my work, right? So work is defined as the integral of P dV, which is essentially the area under these curves. So first thing I want to notice is work 3 to 1 is a constant volume process. Really, there's nothing under this curve. It's a vertical line, right? So there's no work being done for a constant volume process. So right off the bat, I go work 3 to 1 is 0. And then I recognize that 1 to 2 and 2 to 3, if I think about it, I just have a couple of trapezoids. Okay, so let's start with 1 to 2 and do that one. So work of 1 to 2 is just the area of a trapezoid, which is, for those that don't know, it's going to be P1 plus P2 over 2. That's essentially like P average between these two pressures times the change in the volume. Okay, the volume difference. So that's going to be V2 minus V1. It's essentially like, base times, the average height of this is essentially what we have. That's the definition for a trapezoid. So what I have here is P1 again. Let me see here. P1 is 5. Yep, and that's kilopascals. So it's 5 times 10 to the third plus P2, which is 3 times 10 to the third, divided by 2 times the change in volume, V2, is 5 minus 1. And so the work from 1 to 2 is 16 kilojoules. I guess I also can go ahead and throw this guy in because I found that one initially. Now I'll do the same thing for work 2 to 3. Same equation. Okay. This time it's 3 and 1, so it's going to be 3 times 10 to the third plus 1 times 10 to the third divided by 2, and then this time it's 1 minus 5 for the volume. So the final volume is 1, the initial volume is 5, so that's 1 minus 5, which is going to give me negative work, and I actually get a negative 8 kilojoules for process 2 to 3. Okay, so I know Q3 to 1, so I just need to find the other ones. Okay, so let's go ahead and start with the first law on the first cycle, since I know U1 to 2. So again, U1 to 2 equals Q1 to 2 minus work 1 to 2, which, of course, I know now the work 1 to 2, I know U1 to 2, so I can calculate Q1 to 2 to be 15 plus 16 equals 31 kilojoules, okay, which is the heat transfer 1 to 2. Okay. The other thing I know is 3 to 1. I know the work here, and I know the heat transfer. So again, let me start with that one, and I'll actually calculate U3 to 1, and I'll show you how that's going to help me find the last one. So that's going to be 10 minus 0 equals 10 kilojoules. Okay, so now I know U 2 to 1, I know, or I'm sorry, 1 to 2, I know U 3 to 1. What I need to know is that the total change in energy, basically you cycle, because it's a cycle, it has to start and begin at the same property. So the total change in energy has to equal 0, which means U1 to 2 plus U2 to 3 plus U3 to 1 has to equal 0, which means U1 to 2 is 15 plus u2 to 3, which I don't know, plus 10 has to equal 0. Therefore, u2 to 3 has to equal negative 25 kilojoules. Now, I know u2 to 3, I know work 2 to 3. So just like I did here, I can find u2 to 3 equals q2 to 3 minus the work 2 to 3. From that, I can calculate q2 to 3 equals u2 to 3, which is minus 25, plus, what was it? 2 to 3, plus negative 8 equals negative 33 kilojoules, and that is q2 to 3. So now I've got all my works and all my heat transfers. The last thing I need is my thermal efficiency, which is basically the work of the cycle over Q in. Well, the work of the cycle is just adding up all of my works, which is going to be 16 minus 8 plus 0 divided by my positive heat transfers, because it's Q in, which is going to be, we'll do this one, 31 plus 10. I don't include this one because this is actually Q out. Okay. So then from this, I can calculate my thermal efficiency, and I get a thermal efficiency of 0.195 or 19.5%. Okay. So again, we use our definition for work, we use our first law equation, plus the fact that for cycles, the properties start and stop at the same point in order to solve this problem.